we are going to be looking at is Lesson 4.1c, Solving Simultaneous Linear Equations by Graphing. So just as a reminder, guys, we're going to be looking at this idea of systems. And what systems are is a solution where two lines intersect. So if you have one line here, second line here, the whole point of this is to figure out where these 2 points intersect right here. Okay, so let's go over how we would do that. So the first thing is, it says consider the linear equations 2x plus y equals 4 and y equals 4x minus 2. Now what we want to do is graph both equations. So if I start with 2x plus y equals 4, this is written in standard form, and to solve it in standard form, I would find the x-intercept by plugging in 0 for y. So the first thing what we're going to do is find the x-intercept by doing 2x plus 0 equals 4. This would give me 2x equals 4. Divide both sides by 2 to get x is equal to 2. Therefore, I got an answer of 2 when I plugged in 0 for y. And that would be my first point. The second point is I'm going to find the y-intercept. Not that, I'm going to get that by plugging in 0 for x. So that would be 2 times 0 plus y is equal to 4. That would be 0 plus y is equal to 4, which would give me y equals 4. Therefore, if I plugged in 0 for x, I would have an answer of 4. And that's the y-intercept right there. So now I can go ahead and graph this. I'm just going to go ahead and graph from that point to that point and extend all the way down. So that's my first equation. Now the next one, it's in slope-intercept form. So I graph this one in standard form. Now we're going to look at the slope-intercept form. So what we're going to do now is in red, I have this equation y equals 4x minus 2. I start off the y-intercept, which is negative 2, and I put a point there. I just go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. And we can see the two, that line lands right on the green one. So when I draw the line going across, you're going to be able to see that these two lines intersect at that point right there. And that point of intersection is 1, 2. 1, 2. So when I look over here now and it says state the coordinate of where it intersects right there at the point 1, 2. Now remember, algebraically we need to verify that that actually is the solution. So let's go ahead and see how we would do that. So it says using the original equations, verify that the point of intersection satisfies both equations. So I have this point 1, 2, and I'm going to plug this in for x and this in for y over here. So this would be 2 times 1 plus 2, and I just substituted 1 for x and 2 for y, and that's going to equal 4. This would give me 2 plus 2 equals 4, and then get 4 equals 4. Now guys, this is actually verifying that that point is on the line. You have just proven to me that 1, 2 is on this line. Now we're going to do the same over here. This would give me 2 equals 4 times 1 minus 2. This would give me 2 equals 4 minus 2. To get 2 equals 2. And then we're done. And you have verified that this point is on both lines because 2 points can only intersect on one point. And when you verify that a point is on the line, and you get a true statement, that proves that this point is on that line. So this point is on both lines. All right, let's go and look at C. It says in the example above, the point of intersection is the solution to the system of the equation for 2x plus y equals 4 and y equals 4x minus 2. The solutions appear to be simultaneous linear equations is all pairs if any of the number x, y that are solutions of both equations. That is, x, y satisfies both equations. When solved graphically, the solution is the point where the 2 points intersect. Guys, all that is saying is when I plug into a point into the equations, I get a true statement. That is saying that that point is on that line. And graphically, that's where the points cross. So let's go and look at a few more of these. So we're going to graph the following, and I want you to prove. Now really quickly, guys, I have 5, 2. I don't know if it's 5, 2 or 4, 2 on yours. So I think we're going to focus on 4, 2. I believe that's what your notes say. Either way, we're going to get the same idea here. Now this is in slope-intercept form, so I start at negative 5, and I use my slope of up 2 over 1, up 2 over 1, up 2 over 1, so on and so forth. And then I'm going to go ahead and draw this line. It's going to look something like this. Now the next one is negative 4/5 y equals negative 4/5 x plus 5. Here now I'm going to start at the y-intercept of positive 5 and go down 4, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. And we're going to draw these two lines connecting now. And regardless, guys, like I said, I don't know if your notes say 5, 2 or 4, 2. And that doesn't really matter because if you look at both of these guys, this is 5, 2, and it's definitely not. And we look at 4, 2, and while 4, 2 is really close to the red line, it is not on the red line, I believe, and it is definitely not on the blue line. So let's see what this looks like now. It says, is 4, 2 a solution? Well, if this is my x, this is my y, we're going to plug this in for x, and we're going to plug this in for y. To get 2 equals 2 times 4 minus 5, 2 equals 8 minus 5, to get 2 equals 3. And obviously 2 does not equal 3. That is a false statement. So therefore 4, 2 is not on this point and therefore not a solution to the system. We can do the same thing over here, and I'll get 2 equals negative 4/5 times 4 plus 5. This would give me 2 equals negative 16 over 5 plus 25 over 5. I just turned this 5 over 1 into a common denominator. So when I add these up, I'm going to get 2 equals 9 over 5, or 2 equals 1 4/5, or 1.8. And that is also a false statement. So we just figured out that this example where this point is not on either line, because it is not, I ended up with a false statement on both. And just like the previous example, you can see that whether it was this point or this point, none of them land exactly on the line. They're a little over on it. All right. Now what we're going to do is determine whether the given point is a solution to the system of linear equations. We're going to justify your answer by checking both equations. We're going to show all our work. Same idea, guys, as last time. So what I want you guys to do is solve this one on your own. So like pause this video, solve it, and then once you're all done, I want you to go ahead and double check with the video. Alright guys, so you should have watched the video by now. So right now this is my x, this is my y, and I'm just going to plug these in here to get 1 plus 3 times negative 3 equals negative 8. This would give me 1 plus negative 9 equals negative 8, and I'll be left with negative 8 is equal to negative 8. And that is a true statement. Therefore, this point is on this line. Now over here, we're going to go do the same thing. We're going to have 4 times 1 plus negative 3 equals 1. This would give me 4 plus negative 3 is equal to 1. And this would give me 1 equals 1. And that is a true statement as well. Therefore, since it's a true statement on both, I know that is the solution of the system because I get the point where they intersect. There's only one point where two lines intersect, and that is true for both of them, showing that it is the correct solution. All right, we're going to do the same idea over here now. Same idea, guys. I want you to go ahead and solve it on your own, and then I want you to watch the video to confirm you got it right. Okay, so go ahead and pause it now. All right, now that we got that all taken care of, let's go ahead and do this. This is 1/2 times negative 5 minus 0 equals negative 5 over 2. And when I multiply these, remember we just multiply straight across, and this would give me negative 5 over 2 minus 0 is equal to negative 5 over 2. This gives me negative 5 over 2 is equal to negative 5 over 2. Perfect. So that's a true statement. That point is on this line. Now let's go ahead and check over here if it's the same thing. So this would give me then, remember 0 is my x, negative 5 is my y. So this would give me 4 times 0 plus 5 times negative 5 equals 25. This would give me 0 plus negative 25 equals 25. And guys, this is trying to trick you because you're going to end up with negative 25 equals 25. Negative 25 and positive 25 are not the same thing. Therefore, this point is not on the line, and it would not be the solution of the system. Essentially, since it's true on one and false on the other, there'd be a point on one of the lines, but not the second. So this line right here, the point is not located on there, therefore it cannot be the solution to the system. All right, now we're going to graph the given equations on the same coordinate plane to find the solution. We're going to label our lines and verify algebraically that it is a solution. So I have this one. Now it's a little trickier because it's hard to tell what the x and the y intercept are because of this 14. It's really far off the graph, okay? Meaning if I were to plug in 0 for y, 0 for x and solve for y, I would have a y-intercept of 0, 14. So I'm basically going to kind of extend it over a little bit more, so 11, 12, 13, 14. I'm also going to convert this into slope-intercept form by subtracting 2x. And this would give me a new equation of y equals negative 2x plus 14. So I have a slope of negative 2. So from 14, I have this point here, and I'm going to go down 2 over 1, down 2 over 1, and now I have my first point on my graph right there. And if I continue this down 2 over 1, down 2 over 1, we can see that I'm getting more and more points, okay? All right. We can continue this down 2 over 1 and down 2 over 1. And that's my x-intercept. So I gave a ton of points. You don't need that many, obviously, but sometimes that just helps us out seeing it. So we start right here, and we go down. Similar, guys, we're going to convert this into slope-intercept form. So we're going to subtract x on both sides. So subtract x here, subtract x here to get y equals negative x plus 11. So that first imaginary point is up here. It's not quite on our graph. And we're just going to do our slope of going down 1 over 1 point, down 1 over 1 point, down 1 over 1 point. All right, and we can see that the blue line is on the red line, or the blue point is on the red line. That'll help us view it a little easier. And when I connect these dots over here, I can figure out my solution is where the two lines cross. So I'm just going to count. I got to go from here and here over. So this is going over 1, 2, 3. So that's my x value. And then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So 3, 8 is my solution. Now we can't just assume that's the correct solution just by looking at the graph, because there could be some variation or we can mess up on our graph. So we need to prove it algebraically. So I have this point 3, 8. Remember, this is x, this is y. I'm going to plug this in for x. I'm going to plug this in for y. So this will give me 2 times 3 plus 8 is equal to 14. This gives me 6 plus 8 is equal to 14. This gives me 14 is equal to 14. So boom, true statement, that point is on the line. Now we're going to do the same thing over here, 3, 8. Remember, this is my x, this is my y. Let's go ahead and plug these in here. This gives me 3 plus 8 equals 11, and I'm left with a true statement of 11 equals 11. Perfect. So since that's true on both of them, we can confirm that that is the point on the line. Point of intersection. All right, I have 2 of these in slope-intercept form. We're going to start with y equals negative 2x. We're going to put plus 0 just so you know the y-intercept is 0. And since it's a negative 2, we're going to go down 2 to the right 1, down 2 to the right 1, okay? And we're going to be able to draw this line. Looking like that. And I'm going to bring it up on the other side as well. All right, and then over here, I got y equals negative 1/2 x minus 3. So we go to negative 3, 1, 2, 3. Put my point right there, and I'm going to go down 1 to the right 2, down 1 to the right 2. And it looks like this point is where it's going to intersect. All right, that's my 2 lines. And it looks like it's 1, 2. So I go to the right 2, and then I'm going to go down 1, 2, 3, 4. So it looks like the solution is 2, negative 4. Once again, we need to verify it's 2, negative 4 by plugging it in. So this would give me my x, this would be my y. To get negative 4 is equal to negative 2 times 2. To get negative 4 equals negative 4. We're going to do the same thing over here now, 2, negative 4. Plug this in for x, plug this in for y. And this would give me negative 4 is equal to negative 1/2 times 2 minus 3. This gives me negative 4 is equal to these reduce. -1 minus 3 to get -4 is equal to -4. True statements on both of these. Since I have a true statement on both, we're good to go. That proves that that is the solution of the line. All right, so let's go ahead and try this one on your own. I want you to go ahead and figure to see what you guys get. I'm going to give you guys a little hint. This one's a tricky one, okay? You're going to graph it and you're going to be like, this looks a little different, okay? So try it and let's see what we get, okay? All right, guys, so hopefully you saw this one and you notice a weird pattern. So if I start here at my y-intercept at +4 and I go up 2 over 1, up 2 over 1, I'll go ahead and draw my line really quickly. So we're going to go ahead and draw that right like this. And then the next one is, this is not in slope-intercept form, so I'm going to add 2x on both sides. And this is going to give me y equals 2x minus 1. Now I want you to notice these have the same slope, but a different y-intercept. So I'm going to start off at -1. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And even if I go down 2 over 1, down 2 over 1, and you're like, hey, how come these aren't intersecting? It's because these lines are parallel, and parallel lines actually never intersect. So if I said, hey, the solution is where these two lines intersect, where do they intersect? You're like, well, they don't. So since they don't intersect, we would say that this has a no solution. So no matter how far I extend it out, you can see that these lines would not cross. So it is a no solution. All right, so that is one of two of the tricky ones. Let's look at this other tricky one. Now this one's in standard form currently. So what I would do here is I would just plug in 0 for x and 0 for y and solve for the other one. So first one would be x plus 0 equals 3 to get x equals 3. That means I have a point of 3, 0. Next one, it would be 0 plus y equals 3 to get y equals 3 to have the point 0, 3. So here we go, 1, 2, 3, up 1, 2, 3. And we can go ahead and draw this line like so. So the first one's not too bad. Let's go ahead now and look at the second line. Second line is 3x plus 3y equals 9. And same idea, this is in standard form, so if we went ahead and found the x and y intercept, which I'll do in blue now, let's start with the x-intercept. 3x plus 3 times 0 equals 9. So give me 3x equals 9, and when I divide both sides by 3, I'm going to get x is also equal to 3. So the point there would be 3, 0. All right, now over here, let's go ahead and do the y-intercept. Y-intercept, we're going to plug 0 in for x. So give me 3y equals 9. And when I divide both sides by 3, I'm going to get y equals 3. Essentially, I have a point of 0, 3. So if I notice these, it's the exact same point. I'm going to do something a tad different. I'm going to take out a highlighter, and if I connect those 2 points with the highlighter, I want you guys to notice that is exactly the same line as the red line. So essentially what's going on here is when you have two lines that are exactly the same, that are right on top of each other, and I say, hey, where do they intersect? Well, they intersect at every point, which means my solution would be infinite many solutions. And we don't need to verify that since every point's exactly the same. So what is it about the structure of the equations in a system that leads to one solution, infinitely many solutions, or no solutions? So guys, basically what I'm saying here is I give you some equations. I give you two equations. Just by looking at the equations, I want you to tell me, what is it? Is it infinitely many? Is it no solutions? Or one infinitely no solutions or one solution? So let's go ahead and start with this one. A one solution. Explain the structure of the equation. So the only thing that needs to happen for a one solution is they need to have different slopes. That's the only thing. Different slope, and then b value does not matter. So they could be the same or they can be different. All right, so let's go ahead now and look at examples of a system of equations. So that would be something like y equals 2x plus 4. Now remember, this is the slope. That's the only thing that needs to be different. So like y equals like 7x, and then you can choose anything for your b value, like minus 3. And what that would make your graphs look like is just two lines where they cross. Anywhere is where they cross. Now these lines don't represent these equations, but you guys get the idea. When they have different slopes, the equations will cross. Now let's go ahead now and look at no solution. No solution is when they're parallel lines. So what are parallel lines? Parallel lines are when you have the same slope, but different b value, different y-intercept. So the equations there would look like something like y equals 2x plus 3, and then y equals 2x minus 4. So then when you have parallel lines will never intersect. It'll look something like this. So like there, that's parallel lines. All right, the last one out of these examples is infinitely many solutions. Infinitely many solutions means when it's simplified in y equals mx plus b form, they're going to have the same slope and same y-intercept. I'm going to let you guys know right now, I'm not going to give you them like looking exactly the same. So for instance, y equals 2x plus 4, and then on like a test or a homework, I'll give you like 2y equals 4x plus 8. Now I want you to notice, hey, if I divide all these by 2, this would simplify to y equals 2x plus 4. So that's how you'd get the same exact equation. So then when I graph this, it looks like this, and then I would have a line, right on top of it. So it would look like this. Okay, so that's the structure. So without graphing, let's go and determine how many solutions these have. So right here, it's already have the answer. What I always want to do is convert them into slope-intercept form. So this bottom one's already in slope-intercept form. So what we're going to do now is look at the second one, or the first one, and what we're going to do is minus 2x here on both sides. This would give me y equals negative 2x plus 8. Now I want you to notice the slopes are different, and when the slopes are different, it has one solution. So this system has one solution because when both equations are written in slope-intercept form, we see that the equations have different slopes. If graphed, there'd only be one point of intersection. All right, let's go and look at the next one. Same idea, let's convert this into slope-intercept form. Top one's already in slope-intercept form, that's great. Now let's go ahead and look at the bottom one. So we're going to get y all by itself to get the equation y equals negative 2/3 x plus 1. I check the slopes first, they're exactly the same, so therefore they're either going to be same line or parallel. So I just check the y-intercept and they're different, so that means that these two lines would be parallel. Same slope, different y-intercept. So this system has no solution, because when both equations are written in slope-intercept form, we see that the equations have the same slope, but different y-intercept. If graphed, there would be 0 points of intersection. All right, and last one. So the next one, what we are going to be doing is looking at this, and I'm going to minus x on both sides. This gives me y equals negative x plus 5. And then over here, I notice that these are all even numbers. So first thing what I'm going to do is I'm going to add 2x here, add 2x here. This gives me negative 2y is equal to 2x minus 10. And then I'm going to divide each one of these by negative 2. This gives me y equals negative x plus 5. Now looking at these two equations, they are both y equals negative x plus 5. That's great. Since they're the same thing, this has infinitely many solutions. Because both equations are written in slope-intercept form, we have the same slope and y-intercept. If graph, there would be infinite points of intersection. Alright guys, so recall that standard form of linear equations is ax plus by equals c, where a, b, and c represent integers. A and b are not both 0, and a is positive. If one equation in a system is linear, is y equals negative 3 over 2x minus 3, write a second equation with the given requirements. So this is like the challenge problem, guys. I want you to use that equation, y equals negative 3 over 2x minus 3. So I want you to guys use this equation to answer the next 3 questions. And then we're going to go over that together in class. If you have any questions, please raise your hand and let me know. And then after this, you guys can start your homework.